All right, y'all. So back with the second model. So here in this problem, I already had the question written out. It says compare the graph of the functions m of x equals 2 x minus 5 squared minus 2 and h of x equals 4 x minus 5 squared minus 2. So again, the graph does not have to be exact, just accurate. So I've already written out, my coordinate grid and how I just want it to look. And I already wrote out the two different lines, so I took it from the problem and wrote it out for myself. And what I noticed when I wrote them out was that they were in this particular format, but I couldn't remember the name of that format. Can you remember? It's called the H in case you remind us. Probably already said it right now. The vertex form, right? Cool. That's kind of like our focus in today's lesson. So the vertex form is already in vertex form. That already tells me some things back in model 1. I could probably find the vertex, of course. So if we look at our two lines, okay, and we're looking at, first let's look at our A value, because that's what comes first in our vertex form, our A value. Our A value, I'm going to put line 1 stuff right here and then line 2 stuff right here. Our A value for line 1 is 2, and my A value for line 2 is 4. Okay, so those are both positive numbers and they're greater than 1, so we know that our graph is going to open up. We know that at least, right? So, okay, then we also see that we can find the vertex. Vertex is my h and my k, so I come here, x minus h, we have minus 5. So my h is 5. And then plus k, our k is minus 2. So that means that our k is negative. Okay. Then I look at line 2, and I see that that is very similar. So that is the same point. Okay. So I know I can find those two things out. It's asking us to compare these graphs. There's 2 more questions at the bottom that we're going to get to, and because of this information, it's going to help us. What do these graphs have in common, and how are they different? All right. So I know that their A values are different, but their vertex points are the same. So that means they have the same low point because it opens up. There is a minimum. Okay. So they have the same low point on the graph. But we want to see if we can identify what differences they have. So that might come from solving for our y-intercept. So we're going to do that right now. So I have line 2. I'm going to turn this to 0. We're using the same strategy from the beginning video, so you should have that up. I'm actually going to make this that first. Then I'll do my math. 25. You should have Charlie next to you. I do not have my Charlie on me. I have him on the computer. So 25 times 2 is 50. Minus 2 is 48. Is that right, y'all? Are y'all getting that? Are you sure? Let me type it in. Maybe I got that too. Brief intermission while we listen to the music. Yep, there we go, y'all. 48. All right. So that means for this line, our y-intercept is when the line crosses and the x value is 0. And this y value is 48. Wow. High up there. Okay. So let's look at the vertex. The y-intercept of the other problem. So equals 4 using that equation. So what does y equal? X minus 5 squared minus 2. Y equals 4. Instead of that x, we're going to make it a happy 0. Not like in this one. Should take that off. I want to simplify that parentheses first. All right, then we can put all that in our calculator, or we can solve it simply like so, like that, with some Tabitha Brown in there. All right, and that value is 98. I mean, high up there, right? So we have at least two values that we can graph on our line. Here, our y-intercept. X value is 0. Y value is 98. Cool. Box that out so that we can see the difference in our values. Now, let's not get confused. A equals 2 and 4 are not our axis of symmetry. We can find our axis of symmetry from using that vertex, okay? And they'll have the same axis of symmetry. And I'm going to label axis of symmetry AOS, okay? Our axis of symmetry is an equation. So it starts off with x equals, and it's x equals the h value in our vertex. For our vertex is hk, our x equals the h. So in our problem, our x is going to equal our h value, which is 5. So we're going to have an imaginary line that goes down 5. So I'm going to take a quick second, and I'm going to graph the first line because we're comparing these lines, and we want to see what's the difference between them and what's similar. So I have for line 1, let me kind of just split this work in half in case you've been following along. I have the vertex is 5, -2, but I know I have a y-intercept, y'all, of like 0.48. So I'm going to make mine go kind of quick. 10, 20, 30, 40, 50. I'm going to call this 50. 60, 70, 80, 90, 100, 110, 120. Okay? I'm counting mine like that. Again, you are more than welcome to count in whichever order works for you, as long as you are able to draw with accuracy, okay? Then it says, we might have the y value -2. Okay, vertex of 5. So I'm gonna keep these just 1, 2, 3, 4, 5, 6, 7, 8, so on. Right? So 5 and -2. If this is 10, y'all, okay, then I'm gonna make this -10. So my -2 and 5 is probably gonna be like right in here. Again, does not have to be exact, just has to be accurate. Okay, I know that you're talking about the vertex right there. Now this y-intercept is 0 and 48. So I'm gonna go to 0, there's 50, 48's right underneath it probably. So that's gonna be my vertex. Knowing that my axis of symmetry goes down the x value. Okay, I have that. So now I need another symmetrical point that is 5 units away from my y-intercept. The opposite direction, 5 units. So from 5, that will now be 10. So I would say that this is 9, 10. Then I'm going to go up to 50, up to 48 approximately. Because I want to keep them symmetrical. And now I can connect my parabola in a U shape. Boom. So that is line 1. So I'm going to write line 1. Okay? Now, before we move on, I want us to write some things that they have in common already. We know that they have in common, so our sentence stems are going to be both graphs, or you can say lines, have ... And we're going to say that both graphs or lines have the same, what do they have in common? Vertex, which is 5, -2, and they have the same vertex, and they also have the same axis of symmetry. The same vertex and axis. And here we are not going to abbreviate symmetry. We are going to write it out in complete sentence. All right, very awesome, cool. Some things that they have different are their y-intercepts, okay? And we'll, here, let's write that. I'm gonna say line 1 has a different blank than line 2, okay? And my blank here is that they have different y-intercepts. Uh-oh, y'all, need more pencil. And I'm going to put 0.48 and 0.98. All right. So those are two of their differences. All right. Now let's do the second line. So we have the second line, which is y equals, or h of x equals 4x minus 5 squared minus 2. They have the same vertex, so that vertex point is not changing. So I can already label this vertex. We can label this here axis of symmetry. Right? We have a y-intercept. That's what's different, is the y-intercept is 0.98. So I'm going to go up here 90. If this is 100, 98 is about right in there, right? So if I'm using my line of symmetry to get a symmetrical point on the opposite side, this is 0. It's going to come over to 10, and it's going to be at the value 98 on the opposite side. So that's about here. You know, make sure I'm accurate. If I'm not accurate, it's okay. It's not okay. All right, so that looks like 10 and 98. Awesome. So now I'm going to connect those points, and I'm going to use a different color pencil so y'all can see this change. So here we have here, it's going to come to the vertex, but it has to stay on the inside in order to get to that 98. Boom, boom, boom. It always keeps going. Let's keep some arrows. All right, can you see that? Okay, awesome. So that is line 2. There's something different also about line 1 and line 2. And I think it goes back to our A values, A equals 2 and A equals 4. Now, we did mention that they opened up, right? And we did mention that it was going to be positive. But we also talked about in our beginning notes, and I'll bring those up right here real quick, this thing about it, the stretch. It being narrower or wider than the parent function or another function, okay? So then let's look at this. We have line 1 and we have line 2. Line 1 opens up narrower or wider than line 2. I'm going to think wider, okay? Narrower is smaller. Line 2 is narrower or more narrow than line 1. Because it is smaller and squeezed in side of line 1. So that is going to be our last difference. They are not the same stretch or the same width. So we are going to say, and if we can find some more space, we are going to say I'm going to say line 2 is more narrow. Hope you all can see this. Or narrower. So this phrase is going to change. We're going to say this is our stretch. Then line 1. Okay? You can also say line 1, or we can say line 1 is wider than line 2. Okay, we can flip that, right? Wider and narrower, okay, looking at our two graphs. All right, so that was a lot on comparing these two graphs. Okay, you're going to see some problems like that in your guided practice and independent practice. Please pause the video, rewind, go back as many times as you need it in order to get all of this information and understand it. If you have any questions, of course, reach out. You'll have a few more tips in the notes section before you get to some practice. All right.